So I feel like I don't have much left to say. Between the panel that was earlier with Nick, Sahil, Suleiman, we spoke about critical minerals, why they're so critical, why they matter. We spoke about partnerships. We spoke about talent and recycling. But this is what we do at Orion Industrial Ventures. We focus on critical minerals each day, every day in our core business. And I'm just going to quickly take you through the opportunity set, why minerals do matter, and where we're playing and where we see some of the more exciting innovations, many of which were born out of Newlab and other similar organisations. And yeah, we're just going to take you through that. It's not new news to anyone in this room, one, because it's been covered today, but two, because it's becoming more mainstream, that to both electrify our grid and our vehicle fleet, which are two of the largest drivers to decarbonisation, we need an exponential increase in the supply of key minerals and materials. Let's take lithium, which powers batteries. As we know, we need more high-density durable batteries to make widespread EV penetration a reality. Copper powers our renewable energy system. We say on the slide, wind and solar are 7 and 37 times more copper intensive respectively than fossil electricity. And that's before we account for new transmission lines. Every gasoline powered car takes about 66 pounds of copper. Compare that to an EV, it's 4 times that at 240 pounds. Wind turbines need steel, a lot of steel. A 2 megawatt turbine needs about 260 tonnes. That's 300 tonnes of iron ore and a tonne of zinc. What we're saying really is that for the energy transition to become a reality, it's a mineral supply story. The result is an unprecedented increase in demand. Even in the conservative scenario shown here, we're seeing lithium increase 7 times, rare earth over 5 times, and copper, while less in relative terms, in absolute terms is enormous. In the next 2 decades, as a world, we need to mine double the amount of copper mined in history to date. That's over, since time immemorial, double the amount of copper mined in history to date. The good news is that while these are very large numbers in absolute terms, it's very achievable. We're still talking only 3 billion tonnes of metal moved compared to over 7 billion tonnes in oil and gas today. So whilst we're talking about a transition away from a fossil fuel economy to a mineral economy, we're also talking about a far less energy intensive or resource intensive economy, period. The not so good news is that while sufficient resource does exist, it's not easy. It's not easy to find this resource, access it, or recover it using current approaches. First, as is known to many now, the mining sector perennially underinvests in exploration, which is really the lifeblood of new supply, or effectively the R&D of the sector. Industry-wide non-ferrous budgets average only $10 billion a year. The top 5 companies spend about $500 million a year on exploration. Compare that to $50 billion a year that they're returning in dividends. So we're talking 100x returned outside of the company rather than invested in new supply. For deposits that have been recovered, a NIMBY mindset in the Western Hemisphere countries see permitting take almost forever. It's far too long. 16 years from discovery to a new mine. By the time new metal is discovered, we're far too late to hit our net zero targets. For mines that are in production, we're seeing average grades decline. I mean, it was shown here that head grades at the world's largest copper mine are down 40% just in a decade. And the end result is that the supply deficit, a significant supply deficit in new minerals. For other mines, processing facilities, and Nick touched upon this earlier in the case of rare earths, where 99% are located in Russia and China. But the same paradigm applies across all key materials. In nickel, it's difficult to access Indonesian supply. There are export bans there. And we see the same in cobalt out of the DRC, where it's obviously a difficult jurisdiction. Starting to regret having slides now. My clicking's not working so well. No? Now I'll go too far. Yet despite the importance of this challenge, it's actually a relatively underinvested opportunity. Whilst heavy industry, and in that we include steel, cement, ammonia, contributes about 30% of global emissions, in recent years it's attracted just above 10% of venture dollars. It's relatively underinvested, and that's what creates the opportunity. There is good reason for this, though. It's extremely difficult to integrate a new technology, which tends to operate in a batch process, into a continuous 24/7 mine. Not only is it difficult, but it's also highly risky. The cost of disrupting one of these high throughput operations, even for just a few hours, can far outweigh the perceived incremental upside risk that a company would be taking on a new technology. From the startup angle, again, we touched upon this in the panel earlier, these business models are often very capital intensive, and the absence of first-of-a-kind finance sees many companies struggle to get out of a lab and cross the chasm to be viable solutions. Yet, this paradigm's changing. As again we've touched upon, we're seeing policymakers come to the fore at a meaningful scale. In the United States, the Department of Defence under Title III of the DPA has $1.4 billion allocated for projects that include mineral projects, and in addition has a dedicated fund just for rare earths. The DOE has authority to issue up to $55 billion in loans to build the domestic battery value chain. That's $55 billion. It's an enormous amount of non-dilutive capital that can sit underneath early-stage investors in the capital stack. Looking abroad, we're seeing the DFC and EXIM provide finance to technologies in the emerging world, and we're seeing now legislatures in other countries, the UK, Canada and Australia are shown on this slide, but there are others following suit. None of these funding pools alone would justify investing in the sector, but for the right technology targeting a large opportunity being developed by the right team, it clearly changes the risk-return paradigm for early-stage investors, which are starting to focus on critical minerals as a mainstream area within climate tech. This results in opportunities across the value chain. It spans from early-stage discovery to new ways to characterise known resource to optimise production and minimise waste, to new approaches to drill, blast and extract ore in operation, to newer techniques to recover valuable metal from that ore via concentration, leaching and refining, to new methods for how we transport that ore to get it to end market customers. Technology, and again, Danielle touched upon this just in the circular economy speech, but technology also allows us to change the ways how we look at waste products across the value chain and to see mine tailings, wastewater and end-of-life consumer products as new sources of mining through which we can extract valuable metal. From Orion perspective, we're investing across that value chain, but I'm going to focus on a few areas, and particularly those where we can find exciting applications for known and relatively de-risked technologies to apply to mining. There's opportunities to apply advanced AI to legacy data sets, plus new data sources from novel sensors. There are opportunities to apply advanced electrochemistry to replace traditional thermochemical approaches in many mining processes, leveraging cheap green electrons that are available from solar and wind. There's also a history of bioleaching in mining, but we're now only really seeing that just scratches the surface of what we can do with synthetic biology. I'm conscious of time, and I might race through a few areas that we're seeing some exciting opportunities. First, ore body understanding, ore body characterisation as it's known in the sector. In other words, how do we understand the nature of the subsurface and utilise that to make new discoveries and optimise the way that an existing mine operates? We're seeing companies focused on capturing new data sources. That could be geospatial data, data from muon rays, data captured in passive seismic. We're seeing companies use advanced AI and apply that data and newer learning techniques to analyse both historic databases and this new data to identify new deposits, such as what Cobalt Metals and VerAI are doing. And we're seeing other companies like Stratum better map that data to an existing mine to allow for more recoveries. We're seeing companies use data to optimise other mining processes, ranging from drilling and blasting to shoveling. We're particularly excited on new ways to process, in the extraction space, I should say, we're seeing technologies across drilling, technologies across haulage and safety, but we're particularly excited about new technologies for crushing rock. It's unknown to many, but crushing rock, when in mining comminution, takes about 3 to 5% of global electricity. We're seeing new ways from pulse power to physical grinding and microwave technologies emerge. In the processing space, the solutions tend to be more commodity specific. In lithium, and known to many, there's already a wide range of startups developing new membranes, new sorbents and other approaches to recover lithium from both brine and hard rock. Nick touched upon his technology earlier in rare earths, but we're looking for new, both chemical and biological approaches for cleaner, simpler supply of rare earth. We're also particularly excited, and we've got a few Orion portfolio companies in this space, for new approaches to recover copper from chalcopyrite ore, which is about 70% of global copper supply, but is resistant to traditional approaches. And finally, in terms of waste, we're seeing new chemical, electrochemical, biological and physical approaches to recover valuable metal or remine waste products into valuable products. And in summary, and I'm conscious I'm probably well over time, we're more excited by ever by this technology set and the opportunity to apply it in critical minerals. And we think that in doing so, working with others in the room and with firms like Newlab, we can unlock clean, green, locally sourced critical minerals that's necessary to deliver the energy transition. I'll stop there. I think that's it.